Okay, so how do I begin it, Mr. Hall? How do I begin it?
Well, I would just say that we are going to figure out the surface area of this triangle, and I would go with that. I mean, that's primarily what you're doing. Of course, you got A to deal with. I would work on that. Just go right ahead with it.
Okay, so we're going to find the surface area of this, and part A says, is the triangle that forms the base of the prism equilateral, isosceles, or scalene? Okay, so here is a triangle, and I see the lengths is 12, 12, and 12, and they're all the same, so this would be an equilateral triangle. Okay, and then we have to write a numeric expression to represent the surface area of the figure. And I'm going to draw a net for this shape to help me find out the surface area. Of course, you don't have to do that, but it's going to help me with it. So, the net for this shape, I see that the base of it is a rectangle. And then the two sides are also rectangles. Then I see the front is a triangle, and then the back would also be a triangle. So there's my net, okay, and I see the base of it. So to find the area of this rectangle, we do area equals length times width. Okay, so the length would be, so it's 12 by 5.7. Okay, and then for the other one, that'd be 12 times 5.7. And then the other one would be congruent to that one, so it'd also be 12 and 5.7. Okay, and then the triangles. To find the area of a triangle, you have to do area equals a half times base times height. Okay, so the base of this would be 12. Okay, and the height would be 10.39. Okay, and since this front triangle is congruent to the back triangle, the measurements for the back triangle will be the same thing. Okay, so our numeric expression to represent the surface area of the figure, okay, since there is two triangles, you would do 2 times a half, so triangles, half times 12 times 10.39. So sloppy. And then for the rectangles, since all three of those are the same, we could just do 3 times 12 times 5.7. Okay, so there will be our numeric expression. Okay, and the surface area of the figure, we would just add the products of both of those. Okay, so 2 times a half is 1, so you just times 1 times whatever the product of that is. So it'd be 10.39 times 12. Okay, I'm using the standard algorithm of multiplication to do this. 9 times 2 is 18. 3 times 2 is 6 plus 1 is 7. 2 times 0 is 0, and 2 times 1 is 2. Okay, place a 0. And then 1 times 9 is 9. 1 times 3 is 3. 1 times 0 is 0, and 1 times 1 is 1. And then we'd add those. 8 plus 0 is 8. Okay, and then 16. Okay, and I see that there is 2 decimals, so I'd go over 2 on this, and I would get 124.68. Okay, and then we'd have to do this. So that would be 12 times 5.7. I'm going to use the standard algorithm. 1 multiplication. 7 times 2 is 14. 7 times 1 is 7 plus 1 is 8. For placeholder. 5 times 2 is 10. And then 5 times 1 is 5 plus 1 is 6.
Devin Johnson, report to Holly Shouse's room.
Okay, there's 1 decimal place, so you move that over 1. And that would be 68.4, but we're not done because we still have to times that by 3. So 68.4 times 3. 3 times 4 is 12. 3 times 8 is 24 plus 1 is 25. 3 times 6 is 18 plus 2 is 20. Okay, there's 1, so you move it over 1. So I got 205.2. Okay, and then you would just add those together. So I'm going to use the standard algorithm of addition. So 124.68 plus, you got to line your decimals up, 205.2. That'll be 8. That would also be 8. Line your decimals up. Okay, 4 plus 5 is 9. 2. Okay, so I got, for the surface area of this figure is 329.88, and our units of measure is millimeters. Since we was doing area, it's millimeters squared. Okay, so the triangle that forms the base of the prism is equilateral. The numeric expression to represent the surface area of the figure is 2 times a half times 12 times 10.39 plus 3 times 12.5.7, and the surface area of this figure is 329.88 millimeters squared. And I use number 3. I use what I know about how to find the area surface of this figure.
What is that figure?
That figure is a rectangular pyramid. No, it's a triangular prism.
Yes, triangular
Sorry.
prism. Okay, what grade does she deserve, boys and girls? Well, she told us the math practice, and she did have a really good process. It was a long, drawn-out process, but in the end, she got the answers that she needed. And she did have correct answers. I feel like she deserves 100 as well. I think she did a fabulous job.